So now let's talk about precision versus accuracy. Okay, these are two things that you definitely want to pay attention to, and you don't want to confuse as well. So precision. Precision is basically how close of a series of measurements are to one another, okay? Or basically how reproducible they can be. Okay, so let's compare that. Let me just read accuracy. So let me talk about accuracy real fast before I do the comparison. Accuracy is how close the measured value is to the actual value. Okay, the actual value. Somebody's at, the darts. They just throwing them. They're not really good, it looks like. So we're getting some here, 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 here. They're kind of all over the place. This person is not precise, nor are they accurate. Okay, so they're not precise, nor are they accurate. If we go to B though, they came back the next day. They said, "Man, I got to get my practice in." I'm bam, 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 bam. This time, right? We call this being very precise, right? Close of a series of measurements to one another. So they're all close to each other. They're in the top right hand. Unfortunately, they just wasn't in the bullseye. Okay. And then, bam, practice makes perfect. So they come back again. And then what do we see here? They throw out the darts. Bam, 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 bam. They put in that 40 hours, 50 hours, 60 hours of practice. Okay. And what do we see here? It's straight bullseye. One after another, after another, after another. Okay. So this in C is showing me that it's actually precise and accurate. It's precise. All right. It's very precise because all of the darts are by each other. Okay. So they're very precise. But it's also accurate because it's close to the measure value. In this case, our measure value, the thing that we want is the bullseye. We want the bullseye. So this is precise and accurate. Okay. Now, we're going to talk about some errors here real fast. There's two types of errors when it comes to precision and accuracy, or just anything in lab, you think about it. We have random error. So random error is the equal probability of missing correct value on either side. Okay, so usually this is not going to be controlled. So basically, you can think of a random error as something that just randomly happens as it sounds. If you're in lab, something could go dramatically wrong with the experiment, or you're not really sure. This is an example of random error. Okay, so it's just going to miss that value. Okay, and usually it's not controlled, so you're not really sure. Systematic error is a little bit different. So this is going to occur in the same direction each time, and this is often controlled by just correcting an instrument or adding a correction factor towards the data. So for instance, if I'm measuring out, if I'm weighing something and I see that, I continually get, I know that this eraser is supposed to be 10 grams, right? 10 grams. It's supposed to weigh out 10 grams. But, right, if I see in my instrument that I'm consistently keep getting 5 or 6 grams, this is letting me know that I have a system error going on, okay, with this whole instrument. Because I know that this is going to weigh 10 grams, but you're telling me it's 5 grams. So, right, we're getting an error that's occurring in the same direction each time. I'm continually getting 5 grams when I know this is 10 grams. So if I correct whatever I'm weighing it on, okay, that will fix that error. So it can be controlled in that way, okay? So these are just the two errors that you should be familiar with: the random error and systematic error. We're trying to measure something out again. Trying to measure something out. For instance, we're trying to get 10 grams. 10 grams. All right, we got 3 different students. We got student A, student B, and student C. And they all get 4 trials to get, 10 grams measured out precisely and accurate. Okay. So student A, they going to do their first trial and they get 10.49 grams, right? So we're going to see that here with the mass, right? We got 10.49 grams. Trial 2, they did it again, and we're going to see that they got 9.79 grams. And once again, we're trying to get to 10. We're just trying to get to 10. Trial 3, they get a little close, right? We had 9.92 grams. So that's what they get for student A. And then trial 4, we get 10.3. Okay, so a little bit high, but still close to 10. And then for the average of these 4 trials, they get 10.13 grams. Okay. So student A, unfortunately, the goal here was we're trying to get 10 grams. Okay. So were they actually accurate? No, right? Because we got 10.4, 9.7, 9.9, 10.3. And were they precise? Okay, no, right? If it's precise, they should have been very close to each other. Not the case, they're just kind of all over the place, right? Some was up, some was down. Okay. Student B, let's look at student B. So for their first trial, they got 9.78 grams. Okay, cool. Trial 2, they got 9.8. Trial 3, they got 9.7. And then trial 4, they got 9.8. And averaging around 9.79. So student B, we look at the graph here, we can see that they're very precise. All right, they was averaging around the same every single time, coming up a little bit short every single time. But they were getting the same measurement for the most part. Now, they were not accurate because, once again, we want 10 grams. We don't want 9.8. Student C, let's see what student C did. So trial 1, right, they got 10.03 grams. Trial 2, they got 9.9 grams. Trial 3, they got 10.03 grams. Trial 4, they got 9.98 grams, or an average of 10.01 grams. So we look down here at the chart, right, we can see that they were very precise, very precise. They always hovered around the 10 mark exactly. 10.03, 9.99, 10.03, 9.98, right? Right around the 10 mark. So they're very precise. As well as, because they were hovering around that 10 mark, they're very accurate, okay? So, right, because our true match, we wanted 10, and notice the average was 10.01. That's basically 10, okay? So, student C was accurate and precise. All right, 2 things here. They were both of those things. That's how we're going to be thinking about precision versus accuracy.